There are moments in Earth's history when the world changes so suddenly, so completely, that everything afterward feels like a different planet entirely. Imagine waking up one morning to find that the familiar landscape outside your window has been erased overnight. The rivers have changed course. The climate has shifted by dozens of degrees. An entire species have vanished as if they never existed at all. This is not science fiction. This is the story of what happened roughly 12,800 years ago, when our planet experienced one of the most dramatic resets in recorded geological time. Most people have never heard the name Younger Dryas, yet it represents a period so violent and transformative that it rewrote the very foundation of human civilization. For nearly 1,300 years, Earth plunged back into an ice age that should not have existed. Temperatures dropped by as much as 20 degrees Fahrenheit in some regions within decades. Ice sheets that had been retreating for thousands of years suddenly surged forward again. Ocean currents that had flowed in the same patterns for millennia simply stopped. And then, just as abruptly as it began, it ended. Before we dive deeper into this mystery, I would love to know where you are listening from tonight and what time keeps you company as we explore this forgotten chapter of our planet's past. And remember, the images you see are simply guides for your imagination, not requirements for this journey. Thank you for being here with us as we step into the shadows of deep time. The official explanation for the Younger Dryas sounds reasonable enough on the surface. As the last ice age was ending, massive glacial lakes in North America burst through their ice dams, flooding the North Atlantic with fresh water. This disrupted the ocean currents that carry warm water northward, causing a temporary return to ice age conditions. It is a tidy narrative that fits within the boundaries of accepted climate science. But the deeper you dig into the evidence, the more cracks begin to appear in this comfortable story. The problem is not what the official explanation includes, but what it leaves out. Across the globe, from the sediment layers of ancient lakes to the ice cores of Greenland, from the ocean floors to the cave formations deep underground, there are signatures of something far more dramatic than a simple climate oscillation. These signatures tell a story of sudden, catastrophic change that goes beyond anything a disrupted ocean current could produce. In the black mat layers found across North America, researchers have discovered microscopic diamonds that form only under conditions of extreme pressure and heat. These nanodiamonds appear in sediment dated precisely to the beginning of the Younger Dryas period. Alongside them are spherules of melted rock, magnetic particles that could only have formed in temperatures exceeding 2,000 degrees, and concentrations of rare metals typically found in meteorites. This is not the gentle signature of slowly changing ocean currents. This is the fingerprint of cosmic violence. Then there are the megafauna extinctions. At the onset of the Younger Dryas, North America lost roughly 70% of its large animal species. Mammoths, giant ground sloths, saber-toothed cats, cave bears, and dozens of other species that had survived previous climate fluctuations simply vanished from the fossil record. The timing is too precise to be coincidental. Something happened at the boundary between the Pleistocene and our current era that was powerful enough to reshape not just the climate, but the entire web of life across multiple continents. The evidence becomes even more intriguing when we examine what happened to early human cultures during this period. Archaeological sites across North America show a distinct cultural break at the Younger Dryas boundary. The Clovis people, who had spread across the continent with their distinctive stone tools and hunting techniques, disappear from the record almost entirely. When human activity resumes after the climate catastrophe, it carries different technological signatures, different settlement patterns, different ways of life. It is as though the survivors were forced to rebuild their entire world from scattered fragments. But perhaps the most compelling evidence lies not in what science has discovered, but in what humanity remembered. Flood stories appear in the mythologies of cultures separated by oceans and millennia. The Epic of Gilgamesh speaks of waters that covered the earth for days without end. Hindu texts describe cosmic cycles of destruction and renewal marked by great deluges. Native American traditions across dozens of tribes tell of a time when the sky fell and waters rose to swallow the old world. These are not mere metaphors or moral lessons. They are cultural memories of trauma so profound that they shaped the stories people told for thousands of years afterward. The Hopi speak of the end of the Third World, when the earth shook and a great flood destroyed the cities of the ancients. The Cherokee remember the time when the animals warned of coming disaster, and only those who listened survived the rising waters. In the Pacific Northwest, tribal histories describe mountains that exploded and rivers that ran backward during the Great Dying Time. Across the Atlantic, Celtic legends recall the sinking of Lyonesse and the drowning of the summer lands. These stories span continents and cultures that had no contact with one another, yet they describe remarkably similar events occurring at remarkably similar times. What emerges from this convergence of geological evidence, archaeological gaps, and mythological memory is the outline of an event far more dramatic than gradual climate change. Something struck our planet 12,800 years ago with enough force to melt rock, create diamonds, extinguish species, and traumatize human consciousness so deeply that the memory persisted in stories told around fires for hundreds of generations. The question that haunts researchers willing to look beyond the comfortable boundaries of established theory is simple, yet profound. What could cause such widespread, simultaneous devastation? What force could be powerful enough to reset entire ecosystems, erase established cultures, and leave a geological signature visible across multiple continents? The answer may lie not in the slow, predictable processes that typically shape our planet, but in something far more sudden and far more violent. Recent discoveries have pointed toward the possibility of a cosmic impact event, not a single massive asteroid, but a swarm of fragments from a disintegrating comet that struck Earth's atmosphere and surface in a series of explosions spanning hours or days. Such an event would explain the nanodiamonds, the melted spherules, the sudden temperature drops, and the mass extinctions. It would also explain why the evidence appears scattered across such vast distances, rather than concentrated in a single impact crater. The Younger Dryas was not simply a climate event. It was a reset. A moment when the trajectory of life on Earth was violently interrupted and forced to begin again along different paths. The world that emerged from those 13 centuries of cold and darkness was fundamentally different from the world that had existed before. New patterns of weather, new arrangements of species, new ways of life for the scattered human survivors who carried forward only fragments of what their ancestors had known. This interpretation challenges more than just our understanding of ancient climate. It challenges our assumptions about the stability of the world we inhabit. If Earth experienced such a dramatic reset just 12,000 years ago, well within the span of recorded human history, then the foundations of our civilization rest on far more fragile ground than we typically acknowledge. The comfortable notion that catastrophic change happens only over geological timescales, safely removed from human concern, begins to feel like a dangerous illusion. As we continue this investigation, we will explore the mounting evidence that the Younger Dryas represents not an isolated climate anomaly, but part of a larger pattern of catastrophic resets that have shaped our planet's history. We will examine the cosmic cycles that may govern these events, the archaeological evidence of lost civilizations that may have been erased by previous resets, and the unsettling possibility that such events may be more regular and more predictable than mainstream science acknowledges. The story of the Younger Dryas is not just about the past. It is about understanding the true nature of the world we live in and the forces that continue to shape it. Because if the evidence is correct, if our planet truly experienced a cosmic catastrophe that reset the entire trajectory of life just 12,000 years ago, then the most important question is not what happened then, but when it might happen again. The deeper we venture into the evidence surrounding the Younger Dryas boundary, the more we encounter a phenomenon that extends far beyond simple climate disruption. What emerges is a pattern of technological and cultural regression so pronounced that it suggests something more than environmental stress drove human societies to abandon sophisticated practices they had developed over millennia. This regression appears not as a gradual decline, but as an abrupt severing of knowledge transmission that left subsequent generations scrambling to rebuild from scattered fragments. Consider the mystery of megalithic construction techniques that appear to vanish from the archaeological record precisely at the Younger Dryas boundary. Before this period, evidence suggests human societies possessed sophisticated understanding of astronomy, engineering, and stoneworking that enabled them to create monuments requiring mathematical precision we struggle to replicate today. The alignment of structures with celestial events, the transportation and placement of massive stone blocks, the acoustic properties built into chamber designs all point toward knowledge systems far more advanced than simple hunter-gatherer societies should have possessed. Yet after the Younger Dryas period ends, this technological sophistication does not gradually decline. It simply disappears. The archaeological record shows communities reverting to basic survival strategies, abandoning complex settlements, and losing the ability to create the monumental architecture their predecessors had mastered. When megalithic construction eventually resumes thousands of years later, it appears as though people were attempting to recreate techniques they no longer fully understood, working from incomplete memories rather than continuous tradition. This pattern of lost knowledge extends beyond construction techniques into other domains of human activity. Sophisticated astronomical calendars that required generations of careful observation simply vanish from use. Complex trade networks spanning continents collapse and are not re-established for centuries. Even basic technologies like pottery styles and tool-making techniques show dramatic discontinuities that suggest communities were forced to reinvent fundamental aspects of daily life. The implications of this knowledge loss become even more intriguing when we examine the oral traditions that survived the catastrophic period. Many indigenous cultures speak of a time when their ancestors possessed abilities and knowledge that were lost during the Great Destruction. These stories describe not just the physical trauma of floods and fires, but the cultural trauma of wisdom keepers dying before they could pass on their understanding to the next generation. The Lakota speak of the Star People, who taught the early humans about the movements of the sky before the world changed and the teachers departed. Aboriginal Australian traditions describe the Dreamtime ancestors who possessed deep knowledge of the land and its cycles, knowledge that became fragmented when the great waters rose. Andean cultures remember the Viracocha, the foam of the sea, who brought civilization before disappearing during a period of cosmic upheaval. These traditions consistently describe not just catastrophic events, but the specific loss of teachers and knowledge systems that had taken generations to develop. What makes these accounts particularly compelling is their consistency across cultures that had no contact with one another. The pattern repeats across continents with remarkable precision. Advanced knowledge exists, catastrophe strikes, knowledge bearers perish, survivors struggle to preserve fragments of what was lost. This suggests the Younger Dryas period may have represented not just an environmental catastrophe, but an informational catastrophe that severed the transmission lines of accumulated human knowledge. Recent archaeological discoveries have begun to support this interpretation in unexpected ways. Excavations at sites like Göbekli Tepe in Turkey reveal sophisticated stoneworking and astronomical alignments that predate the Younger Dryas period by several thousand years. These monuments required coordinated effort from large groups of people, suggesting complex social organization and shared knowledge systems. Yet the site appears to have been deliberately buried around the time of the Younger Dryas event, as though the builders themselves chose to conceal their work rather than abandon it to destruction. Similar patterns emerge at other ancient sites around the world. Complex structures that predate the official timeline of civilization show evidence of careful burial or concealment, rather than simple abandonment. This raises disturbing questions about what the builders knew and when they knew it. Did some human societies possess advance warning of the catastrophic events that were approaching? Did they attempt to preserve their knowledge and structures by burying them, hoping future generations would rediscover what they had created? The possibility becomes even more unsettling when we examine the precision with which some of these ancient sites align with astronomical events that occur on cycles spanning thousands of years. The builders would have needed detailed observations passed down across multiple generations to achieve such accuracy. This implies not just sophisticated knowledge, but sophisticated systems for preserving and transmitting that knowledge across time. The fact that these systems appear to have been deliberately interrupted rather than gradually abandoned suggests the catastrophe that ended them was both sudden and anticipated. But the mystery deepens when we consider the speed with which complex societies re-emerged after the Younger Dryas period ended. Agriculture appears almost simultaneously across multiple continents with remarkable sophistication. Cities arise with advanced planning and engineering. Writing systems develop with surprising complexity in relatively short timeframes. This rapid re-emergence of civilization suggests that knowledge was not entirely lost during the catastrophic period, but rather preserved in some form that allowed for accelerated redevelopment. Some researchers propose that small groups of survivors maintained fragments of pre-catastrophe knowledge in isolated refugia, emerging after the climate stabilized to seed new civilizations with inherited wisdom. This would explain both the regressions seen during the Younger Dryas period and the rapid advancement that followed its end. It would also explain why so many early civilizations seem to appear fully formed rather than showing gradual development from simpler antecedents. The genetic evidence supports this interpretation in subtle but significant ways. Human populations show clear bottlenecking events that correspond to the Younger Dryas period, suggesting dramatic population reductions across multiple continents. Yet the genetic diversity that survives this bottleneck includes lineages that suggest small groups maintained connection across vast distances, as though networks of knowledge preservation continue to operate even during the most difficult periods. Archaeological evidence of these survivor networks appears in the form of shared symbolic systems that span continents during the immediate post-Younger Dryas period. Similar geometric patterns, astronomical alignments, and construction techniques appear in widely separated regions, with timing that suggests coordinated redevelopment rather than independent invention. These similarities are too precise and too widespread to represent coincidental cultural evolution. The most intriguing aspect of this survivor network hypothesis is what it suggests about the nature of the original catastrophe. If some groups were able to prepare for and survive the Younger Dryas events, it implies these events may not have been entirely unexpected. Perhaps the astronomical knowledge preserved in ancient monuments was not purely ceremonial, but practical. Perhaps the careful tracking of cosmic cycles served as an early warning system for catastrophic events that follow predictable patterns. This possibility transforms our understanding of the Younger Dryas from an isolated climate anomaly into something far more significant. If the evidence is correct, if human societies did possess advanced knowledge of catastrophic cycles, then the event that reset our planet 12,000 years ago may represent not a random disaster, but a predictable phase in a larger cosmic pattern that continues to influence our world today. The question that emerges from this investigation is both simple and profound. If the Younger Dryas represented a cyclical catastrophe that was anticipated by some ancient societies, what does the astronomical knowledge they preserved tell us about when such events might occur again? And more importantly, are there signs in our current cosmic environment that suggest we may be approaching another such cycle? We may be approaching another such cycle. The astronomical component of this mystery reveals layers of complexity that stretch our understanding of what ancient peoples could have known and how they could have known it. When we examine the celestial alignments embedded in pre-Younger Dryas monuments, we find calculations that require not just careful observation, but multi-generational data collection spanning centuries or even millennia. These alignments track precession cycles, planetary conjunctions, and stellar movements that unfold over timescales far exceeding individual human lifespans. What makes this astronomical knowledge particularly unsettling is its apparent focus on catastrophic events rather than agricultural or ceremonial purposes. Many of the most precisely aligned monuments point towards specific configurations of celestial bodies that correlate with periods of cosmic debris bombardment. The builders seem to have been tracking not just the regular movements of planets and stars, but the irregular appearances of cometary fragments and meteor swarms that follow long-period orbital patterns. The Taurid meteor stream presents a compelling example of this phenomenon. Modern astronomy has identified this debris field as the remnant of a massive comet that disintegrated roughly 20,000 years ago, creating a stream of fragments that Earth encounters twice yearly. But within this stream are larger objects, some potentially kilometers in diameter, that follow more complex orbital patterns, bringing them into Earth's vicinity at intervals measured in millennia rather than months. Recent computer modeling suggests that our planet passed through an unusually dense region of this debris field approximately 12,800 years ago, precisely coinciding with the onset of the Younger Dryas period. The bombardment would have lasted for days or weeks, creating the multiple impact signatures found in geological layers worldwide. But the most disturbing aspect of this discovery is the realization that Earth encounters dense regions of the Taurid stream on a predictable schedule. Ancient astronomical records from various cultures contain detailed observations of celestial phenomena that align remarkably well with the calculated orbital periods of these cosmic debris encounters. Mesopotamian tablets describe the return of the fire from heaven in cycles spanning thousands of years. Mayan calendars track long counts that correspond to the orbital mechanics of cometary fragments. Hindu texts speak of cosmic cycles of destruction and renewal that match the periodicity of major meteor stream encounters with startling precision. These astronomical traditions suggest that ancient observers not only witnessed catastrophic cosmic bombardments, but developed sophisticated methods for predicting their return. The mathematical complexity required for such predictions rivals modern orbital mechanics in its precision. Yet the knowledge appears to have been encoded in mythological and religious systems rather than scientific treatises, perhaps as a way of preserving crucial information across the cultural disruptions that followed each catastrophic event. The implications of this interpretation extend far beyond academic curiosity about ancient astronomy. If the Younger Dryas bombardment was indeed a predictable event within a larger cosmic cycle, then the question becomes unavoidable. Where are we now within that cycle? The orbital mechanics that brought devastating fragments to Earth 12,000 years ago continue to operate according to the same gravitational laws. The debris streams that created the catastrophic bombardment still exist, still follow their ancient paths through the solar system. Modern astronomical observations have identified several concerning developments within the cosmic environment surrounding Earth. The Taurid stream shows signs of increased activity, with larger fragments detected in recent decades. Other debris fields associated with ancient cometary breakups show orbital perturbations that could bring them into Earth's vicinity within the coming centuries. Most unsettling of all, some of the astronomical alignments tracked by ancient monuments are approaching repetition for the first time since the Younger Dryas period. The scientific community remains divided on the implications of these observations. Mainstream astronomy maintains that the probability of significant cosmic bombardment remains extremely low on human timescales. But a growing number of researchers argue that this assessment fails to account for the cyclical nature of cosmic debris encounters. and the clear evidence that such events have occurred repeatedly throughout Earth's history. The debate has taken on increased urgency as new discoveries continue to emerge from the geological record. Impact signatures, similar to those found at the Younger Dryas boundary, have been identified at multiple earlier periods in Earth's history, suggesting that cosmic catastrophes may be far more regular than previously assumed. These earlier events show the same patterns of mass extinctions, climate disruption, and cultural collapse that characterize the Younger Dryas period. Each of these ancient catastrophes appears to have reset the trajectory of life on Earth, forcing evolution and human development along new pathways. The survivors of each event carried forward fragments of knowledge and genetic information from the previous era, but always within the context of dramatically altered environmental conditions. This pattern of catastrophic reset, followed by rapid redevelopment, may represent the fundamental rhythm of life on our planet. What makes this pattern particularly relevant to our current situation is the realization that modern human civilization has developed during what appears to be an unusually quiet period in the cosmic bombardment cycle. Our technologies, our social systems, our entire understanding of how the world works has emerged during a span of relative cosmic calm that may be approaching its end. The astronomical knowledge preserved by ancient cultures suggests they understood this cyclical nature of cosmic catastrophe and developed systems for preserving crucial information across the periods of destruction and rebuilding. Modern science may have lost this long-term perspective, focusing instead on the detailed study of processes that operate on shorter timescales. We have gained tremendous knowledge about the mechanics of our world, but perhaps lost sight of the larger patterns that govern its long-term evolution. The question that emerges from this investigation is whether modern humanity possesses the wisdom to recognize and prepare for cyclical catastrophes that our ancestors clearly anticipated. We have technologies far more sophisticated than anything available to ancient civilizations, but we may lack the cultural systems necessary for preserving knowledge across catastrophic disruptions. Our centralized information storage systems, our specialized knowledge domains, our reliance on complex infrastructure may actually make us more vulnerable to systemic collapse than the distributed, resilient knowledge preservation methods developed by earlier cultures. As we continue to investigate the cosmic cycles that may govern catastrophic events on Earth, we must also examine what our ancestors understood about survival and recovery. The evidence suggests they developed not just methods for predicting catastrophic events, but sophisticated strategies for ensuring that crucial knowledge and technologies could survive the chaos and emerge intact in the rebuilt world that followed. The study of these ancient survival strategies may prove more valuable than any technological advance in determining whether human civilization can successfully navigate the cosmic challenges that may lie ahead. Because if the evidence is correct, if we are indeed approaching another phase in the catastrophic cycle that reset our world 12,000 years ago, then our survival may depend not on our ability to prevent such events, but on our wisdom in preparing for them. The archaeological evidence from survivor sites reveals something even more extraordinary than sophisticated astronomical knowledge. It reveals a deliberate strategy for cultural resurrection that operated on timescales spanning millennia. These ancient peoples did not simply prepare for catastrophe. They engineered systems designed to rebuild civilization from its ashes with remarkable speed and precision. Hidden within the deepest layers of sites like Göbekli Tepe and other pre-Younger Dryas monuments, researchers have discovered what can only be described as instruction manuals carved in stone. These are not simple decorative motifs or religious symbols, but detailed technical diagrams showing everything from water management systems to astronomical calculation methods. The information is encoded in geometric patterns and symbolic languages that could survive any level of cultural disruption. What makes these instruction sets particularly sophisticated is their layered structure. Surface-level carvings provide basic survival information, agriculture techniques, and simple tool-making. deeper analysis reveals more complex engineering principles, mathematical relationships, and astronomical calculations. The most advanced information appears to be encoded in the precise dimensions and alignments of the structures themselves, requiring detailed measurement and analysis to decode. This suggests the builders understood that knowledge transmission across catastrophic periods would require multiple redundant systems. Oral traditions might be lost, written records might be destroyed, but stone monuments could preserve crucial information for thousands of years if properly designed. The knowledge would be there, waiting for survivors intelligent enough to recognize and decode it. The genius of this preservation system becomes apparent when we examine how quickly complex civilizations emerged after the Younger Dryas period ended. The speed of development was not natural evolution from primitive beginnings, but rapid reconstruction, guided by inherited blueprints. Agriculture did not develop slowly through trial and error. It appeared almost simultaneously across multiple continents, with sophisticated techniques already refined. Urban planning emerged with advanced understanding of drainage, defense, and resource management that would have taken centuries to develop through experience alone. Even more telling is the consistency of early post-Dryas civilizations in their approach to monument construction and astronomical observation. Despite being separated by vast distances and having no apparent contact, these emerging cultures built similar structures, tracked similar celestial events, and encoded similar mathematical principles in their architecture. This was not coincidental cultural evolution, but coordinated reconstruction following shared templates. The survivor network hypothesis gains additional support from genetic studies showing that certain rare bloodlines appear to have been deliberately preserved through the Younger Dryas bottleneck. These lineages show evidence of positive selection for traits associated with memory retention, mathematical ability, and resistance to environmental stress. It appears that ancient societies may have identified individuals most capable of preserving and transmitting crucial knowledge, ensuring their genetic line survived even the most severe population reductions. Modern DNA analysis reveals that these preserved lineages correlate strongly with populations that later became the founding dynasties of early civilizations. The priest kings of Mesopotamia, the pharaonic bloodlines of Egypt, the Brahmin castes of India, all show genetic markers suggesting descent from populations that survived the Younger Dryas period in organized groups rather than as scattered refugees. This implies that the rebuilding of civilization was not random, but guided by specific families carrying forward specific knowledge traditions. The implications of this discovery extend far beyond ancient history. If the evidence is correct, if human civilization has survived multiple catastrophic resets through deliberate preservation strategies, then the technologies and social systems we consider modern innovations may actually be rediscoveries of ancient knowledge. Our rapid technological development over the past few centuries may represent not unprecedented human achievement, but the natural acceleration that occurs when inherited blueprints begin to guide development. This interpretation helps explain several anomalies in the historical record that have long puzzled researchers. The sudden appearance of complex mathematical concepts in early civilizations, the sophisticated astronomical knowledge of cultures that supposedly lacked advanced instruments, the engineering capabilities demonstrated in ancient monuments that exceed what their tools should have enabled. All of these anomalies make sense if early civilizations were working from inherited technical manuals rather than developing knowledge from scratch. But perhaps the most significant implication is what this reveals about our current position in the cycle. Modern archaeology and astronomy have begun to rediscover knowledge that appears to have been encoded in ancient monuments for thousands of years. We are deciphering astronomical alignments that track cosmic debris cycles, uncovering engineering principles embedded in megalithic construction, and recognizing mathematical relationships built into sacred architecture. This suggests we may be approaching the point in the cycle where preserved knowledge becomes fully accessible again. The timing is significant because it coincides with mounting evidence that Earth is entering another period of increased cosmic activity. The same astronomical conditions that ancient monuments appear to track are beginning to repeat. The debris streams that created the Younger Dryas bombardment are approaching configurations similar to those that existed 12,000 years ago. If the ancient preservation systems are functioning as designed, this should be precisely when the deepest levels of encoded knowledge become relevant again. Recent discoveries support this interpretation in disturbing ways. Archaeological teams working at major ancient sites report finding previously unknown chambers and passages that seem to have been designed for activation at specific times. These spaces contain artifacts and inscriptions that were clearly intended for discovery during periods of cosmic threat. The preservation methods used in these chambers suggest their builders expected them to remain sealed for thousands of years before being opened. Most unsettling of all are the astronomical devices found in some of these sealed chambers. These instruments show wear patterns indicating they were used extensively before being carefully stored away. They are calibrated to track celestial phenomena that occur on cycles spanning millennia, with particular focus on periods when Earth encounters dense regions of cosmic debris. The precision of these instruments rivals modern astronomical equipment in their ability to predict cosmic bombardment events. The discovery of these devices raises profound questions about what ancient civilizations knew about cosmic cycles and when they knew it. The instruments appear to have been created not for academic curiosity, but for practical prediction of existential threats to human civilization. Their careful preservation suggests the builders understood that this knowledge would be crucial for survival during future catastrophic periods. But the most disturbing aspect of these discoveries is what they suggest about current cosmic conditions. When modern astronomers calibrate these ancient instruments and run their calculations forward to the present day, the results point toward an imminent period of increased bombardment risk. The cosmic alignments being tracked by these devices are approaching repetition for the first time since they were created. This convergence of archaeological discovery and astronomical observation suggests we may be living through the transition period that ancient preservation systems were designed to address. The knowledge encoded in stone monuments, the bloodlines preserved through genetic bottlenecks, the technologies stored in sealed chambers. All of these elements appear to be activating simultaneously as cosmic conditions begin to match those that necessitated their creation. The question that emerges from this investigation is whether modern humanity possesses the wisdom to recognize and utilize the survival strategies left by our ancestors. We have rediscovered their astronomical knowledge, decoded their preservation systems, and identified their genetic lineages. But do we have the cultural flexibility to implement their solutions? Can a globalized technological civilization adapt the distributed resilience strategies that enabled previous cultures to survive catastrophic resets? The answer may determine not just whether human civilization survives the coming cosmic challenges, but what form that survival takes. Because if the pattern holds, if we are indeed approaching another catastrophic reset similar to the Younger Dryas event, then the next phase of human development will be shaped by how well we learn from those who face similar challenges before us. The knowledge they preserved may be our best guide for navigating what lies ahead. The convergence of ancient warnings and modern astronomical observations creates a picture that becomes increasingly difficult to ignore. As we piece together the fragments of inherited knowledge with contemporary scientific data, we discover that the cosmic threat our ancestors spent millennia preparing for may not be a distant theoretical concern, but an approaching reality that demands immediate attention. Modern space agencies have begun to acknowledge what ancient astronomical records have been indicating for thousands of years. The European Space Agency's recent observations of the Taurid meteor stream reveal density fluctuations that follow predictable patterns, with peak bombardment periods occurring roughly every 2,000 to 3,000 years. NASA's near-Earth object detection systems have identified an increasing number of larger fragments within debris fields that were previously thought to contain only small particles. What makes these observations particularly concerning is their correlation with the astronomical calculations preserved in ancient monuments. When researchers input current orbital data into the prediction systems encoded in megalithic structures, the results consistently point toward a period of increased cosmic activity beginning within the next several decades. The margin of error in these ancient calculations appears to be remarkably small, suggesting a level of observational precision that should not have been possible without sophisticated instruments. The geological record supports these astronomical predictions in ways that extend beyond simple meteor impact signatures. Ice core data from Greenland and Antarctica shows cyclical patterns of atmospheric disruption that correlate precisely with the cosmic bombardment periods indicated by ancient astronomical records. These disruptions manifest as chemical signatures consistent with massive atmospheric explosions, widespread fires, and sudden climate shifts that match the effects predicted by cosmic impact models. But perhaps the most telling evidence comes from studying the intervals between these disruption periods. The geological record shows that Earth experiences major cosmic bombardment events with remarkable regularity, following cycles that align almost perfectly with the long-term astronomical observations preserved in ancient monuments. This suggests that our ancestors were not simply recording random catastrophic events, but tracking a predictable pattern that continues to operate according to the same cosmic mechanics. Recent archaeological discoveries have revealed that some ancient cultures possess knowledge of these cycles that extends far beyond simple observation and recording. Excavations at sites across the globe have uncovered what can only be described as early warning systems, sophisticated networks of monuments and observation posts designed to track approaching cosmic threats with precision that rivals modern astronomical equipment. These ancient observation networks show evidence of coordinated operation across vast distances. Monuments in Egypt align with structures in Peru that correspond to sites in Asia, all tracking the same celestial phenomena with mathematical precision that requires constant communication and data sharing. The scale of coordination suggests these ancient astronomers understood that cosmic threats operate on global scales, requiring global response systems. The preservation methods used by these observation networks reveal an understanding of information transmission that goes far beyond simple stone carving. Recent analysis has revealed that many megalithic sites contain acoustic properties that could transmit coded information across great distances. Sound frequencies generated by specific chamber designs could carry astronomical data between networked sites, creating a communication system that could function even during periods of social collapse. Even more sophisticated are the magnetic properties built into certain ancient structures. These monuments appear to have been constructed using materials and techniques that create detectable electromagnetic signatures aligned with cosmic events. Modern instruments can measure these signatures and decode them into astronomical information that remains accurate thousands of years after the monuments were built. The discovery of these ancient technologies forces us to reconsider what we know about the capabilities of pre-modern civilizations. The level of sophistication required to create such systems suggests that our ancestors possessed not just advanced astronomical knowledge, but advanced understanding of physics, engineering, and information theory that we are only beginning to rediscover. But the most disturbing aspect of these discoveries is what they reveal about the urgency with which ancient cultures approached cosmic threat preparation. The massive investment of resources and labor required to create these observation and preservation systems suggests these societies understood they were facing existential threats that demanded coordinated global response. They were not preparing for minor inconveniences, but for events capable of ending civilizations. The genetic evidence provides additional context for understanding the scope of ancient preparation efforts. DNA analysis of populations that survived previous cosmic catastrophes reveals deliberate selection for traits that enhance survival during extreme environmental disruption. These populations show enhanced resistance to radiation exposure, improved ability to process alternative food sources during agricultural collapse, and increased cognitive flexibility for rapid adaptation to changed circumstances. Modern genetic studies suggest that these adaptive traits remain present in current human populations, though at lower frequencies than during immediately post-catastrophic periods. This implies that the genetic toolkit necessary for surviving cosmic catastrophes continues to exist within human populations, ready to be activated when environmental pressures select for these characteristics. The distribution of these survival genetics corresponds closely with populations that maintain oral traditions describing cosmic catastrophes and cyclical destruction events. Indigenous cultures across multiple continents carry genetic markers associated with catastrophe survival, alongside detailed mythological accounts of cosmic disasters that match the astronomical predictions encoded in ancient monuments. This convergence of genetic, mythological, and astronomical evidence suggests that knowledge of cosmic threat cycles has been preserved through multiple redundant systems spanning thousands of years. The information exists not just in stone monuments and written records, but in the biological inheritance and cultural memory of populations specifically selected for their ability to transmit crucial survival information across catastrophic periods. The question that emerges from this investigation is whether modern civilization possesses the institutional flexibility to respond effectively to cyclical threats that operate on timescales exceeding normal planning horizons. Our political systems, economic structures, and social organizations are optimized for addressing challenges that unfold over years or decades, not millennia. We lack the cultural mechanisms that enabled ancient societies to maintain focus on long-term cosmic threats across multiple generations. Yet the mounting evidence suggests that such long-term thinking may be essential for navigating the cosmic challenges that appear to be approaching. If the ancient astronomical calculations are correct, if the geological patterns continue to hold, and if modern space observations are accurately tracking increasing cosmic activity, then humanity may be approaching a period when the survival strategies preserved by our ancestors become immediately relevant. The implications extend beyond simple disaster preparedness into fundamental questions about how human civilization should organize itself in relation to cosmic cycles that dwarf normal historical timescales. We may need to develop new institutions capable of maintaining vigilance and preparation across centuries, new technologies capable of detecting and deflecting cosmic threats, and new cultural systems capable of preserving crucial knowledge through periods of social disruption. The ancient preservation systems suggest that such long-term institutional thinking is possible, but only if societies are willing to invest significant resources in preparing for threats that may not materialize for generations. Modern civilization faces the challenge of learning from ancestors who understood cosmic threat cycles, while adapting their solutions to contemporary conditions that they could never have anticipated. The next phase of this investigation must examine what specific preparations ancient cultures made for cosmic catastrophes and how their solutions might be adapted for modern conditions. Because if we are indeed approaching another cosmic reset period, the survival strategies developed by our ancestors may be the key to ensuring that human civilization not only survives the coming challenges, but emerges stronger and wiser from the experience. Time may be shorter than we think. The cosmic clock that our ancestors spent millennia learning to read may be approaching another hour that demands our full attention. Whether we are prepared to listen to its warnings may determine the future trajectory of everything we have built. The archaeological record reveals that ancient preparation strategies operated on principles fundamentally different from modern disaster planning. Rather than attempting to prevent catastrophic events, these cultures focused on ensuring continuity through them. Their approach was not resistance, but resilience. Not avoidance, but adaptation. The evidence suggests they understood something about cosmic cycles that modern civilization has forgotten in its pursuit of technological control over natural forces. Deep beneath the sands of the Sahara, ground-penetrating radar has revealed networks of underground chambers that extend for hundreds of miles in geometric patterns that mirror astronomical alignments. These subterranean complexes show no signs of habitation, but contain evidence of massive storage systems designed to preserve resources across extended periods of surface disruption. The chambers are sealed with materials that could withstand extreme temperature fluctuations and atmospheric pressure changes consistent with cosmic bombardment effects. Similar underground networks have been discovered on every continent, always in locations that correspond to areas of geological stability during periods of cosmic stress. The positioning is not random. These sites were selected based on sophisticated understanding of how cosmic impacts affect crustal dynamics, atmospheric circulation, and hydrological systems. The builders understood that survival required not just protection from direct impact effects, but adaptation to the cascading environmental changes that follow cosmic catastrophes. The contents of these preservation chambers reveal preparation strategies that extend far beyond simple resource storage. Seeds are preserved using techniques that ensure viability across millennial timeframes. Tool designs are encoded in materials that will not degrade under extreme conditions. Knowledge systems are preserved through multiple redundant methods that could function even if most transmission pathways were severed. Most remarkably, these chambers contain what appear to be genetic preservation systems designed to maintain crucial biological diversity through population bottlenecks. Modern analysis of these ancient genetic preservation methods reveals techniques that rival contemporary biotechnology in their sophistication. Samples are stored using natural preservation matrices that maintain cellular integrity across geological timescales. Selection criteria focus on genetic variants that enhance survival during environmental extremes, while maintaining cognitive abilities necessary for rapid cultural reconstruction. The precision suggests these ancient biotechnologists understood principles of genetic stability and inheritance that we are only beginning to rediscover. But perhaps the most sophisticated aspect of ancient preparation systems was their approach to knowledge preservation across cognitive disruption. They understood that cosmic catastrophes do not simply destroy infrastructure and kill populations. They disrupt the psychological and social foundations that enable complex knowledge transmission. Trauma, isolation, and resource scarcity create conditions where even surviving populations lose the ability to maintain sophisticated cultural practices. To address this challenge, ancient preservation systems encoded crucial knowledge in forms that could function even under conditions of severe cognitive and social disruption. Information was embedded in rhythmic patterns that could be maintained through oral transmission, even when written language was lost. Technical procedures were encoded in ritual practices that could preserve accurate procedures, even when understanding of underlying principles was forgotten. Mathematical relationships were embedded in architectural forms that could guide reconstruction, even when the original builders were gone. The genius of these preservation methods becomes apparent when we examine how quickly complex practices re-emerged after previous catastrophic periods. Agricultural techniques that should have required centuries of development appeared almost simultaneously across continents, with sophisticated refinements already incorporated. Astronomical observation methods emerged with precision that implied continuous knowledge transmission, despite massive population disruptions. Engineering capabilities manifested in post-catastrophic construction projects that exceeded what newly settled populations should have been able to achieve. This pattern suggests that ancient preservation systems were designed to create what researchers now term cognitive resurrection. Knowledge was not simply stored for later retrieval, but embedded in forms that could actively guide the reconstruction of complex practices, even when direct understanding was lost. The information was alive in ways that ensured it would emerge naturally as conditions stabilized and populations recovered. Modern neuroscience is beginning to understand how these cognitive resurrection systems might have functioned. Recent research reveals that human brains possess remarkable capacity for pattern recognition that operates below conscious awareness. Information embedded in environmental structures, social practices, and genetic inheritance can guide behavior and decision-making, even when individuals have no explicit knowledge of the underlying principles. Ancient preservation systems appear to have been designed to exploit these unconscious cognitive processes. The implications for contemporary preparation strategies are profound. Modern approaches to catastrophe preparation focus primarily on maintaining existing systems through disruption. We build redundant infrastructure, create backup databases, and develop emergency protocols designed to preserve current capabilities. But ancient preservation systems suggest that true resilience requires preparing for the complete reconstruction of civilization, rather than simply maintaining it through temporary challenges. This reconstruction-based approach requires fundamentally different preparation strategies. Instead of focusing solely on preserving current technologies, we must identify and preserve the underlying principles that enable technological development. Instead of maintaining current social structures, we must preserve the cultural knowledge that enables rapid social reorganization. Instead of protecting current populations, we must ensure that surviving populations possess the genetic and cognitive diversity necessary for rebuilding complex societies. The evidence from ancient preservation systems suggests that such preparation is possible, but requires commitment to timescales that exceed normal institutional planning horizons. The underground preservation networks discovered across the globe represent investments spanning multiple generations, coordinated efforts that required sustained commitment across centuries of construction and maintenance. Modern civilization would need to develop similar long-term thinking to implement effective cosmic catastrophe preparation. Recent advances in material science and biotechnology provide tools that could enable preservation strategies far more sophisticated than anything available to ancient cultures. We can create storage systems that maintain integrity across geological timescales. We can preserve genetic information with precision that ensures accurate reconstruction across any conceivable bottleneck period. We can encode knowledge in quantum systems that could survive electromagnetic disruptions exceeding anything in the geological record. But the technical capability for advanced preservation systems is meaningless without the cultural commitment to implement them. Ancient preservation networks required societies willing to dedicate massive resources to preparing for threats that might not manifest for centuries. They required political systems capable of maintaining focus on long-term survival across multiple generations of leadership changes. They required cultural values that prioritize species survival over immediate material prosperity. Modern civilization faces the challenge of developing such long-term institutional thinking while operating within political and economic systems optimized for short-term results. The evidence suggests that previous civilizations that successfully navigated cosmic catastrophe cycles developed cultural mechanisms that enabled sustained commitment to millennial-scale preparation projects. We lack such mechanisms, but we possess unprecedented capabilities for creating them if we choose to do so. The astronomical evidence indicates that such choices may need to be made within decades rather than centuries. The cosmic alignments tracked by ancient monuments are approaching repetition with accelerating precision. Modern space observation systems are detecting increased activity in debris fields that have remained relatively quiet throughout recorded history. The convergence of ancient warnings and contemporary observations suggests that the preparation window may be closing faster than previously anticipated. The question that defines our immediate future is whether modern humanity possesses the wisdom to learn from civilizations that successfully navigated cosmic catastrophe cycles while adapting their solutions to contemporary conditions. We stand at a unique point in history where we have access to both ancient preservation knowledge and advanced technological capabilities. The combination could enable preparation strategies that exceed anything previously attempted, but knowledge and capability are meaningless without commitment to implementation. The evidence preserved by our ancestors suggests that cosmic catastrophes are not random disasters, but predictable phases in cycles that continue to operate according to unchanging cosmic mechanics. If we are approaching another such phase, then our response will determine not just whether human civilization survives, but what form that survival takes. The choice we face is not whether to prepare for cosmic catastrophe, but how to prepare. The ancient preservation systems offer proven strategies for ensuring continuity through catastrophic disruption. Modern technology offers capabilities for implementing those strategies with unprecedented effectiveness. The missing element is cultural commitment to long-term thinking that prioritizes species survival over immediate convenience. Time may be running out for developing such commitment. The cosmic clock that our ancestors learned to read with such precision continues to tick toward alignments that have historically triggered catastrophic resets. Whether we are prepared when those alignments complete may determine the trajectory of human development for millennia to come. The knowledge exists, the technology exists. The question is whether the will exists to use them while we still can. The threads we have followed through the shadows of deep time converge on a single, inescapable truth. The Younger Dryas was not an anomaly, but a pattern. Not a random catastrophe, but a scheduled reset. The evidence stretches across continents and millennia, written in stone, preserved in DNA, and whispered through the oral traditions of every surviving culture on Earth. Our ancestors understood what we have forgotten. They prepared for what we have ignored. Whether we possess the wisdom to heed their warnings remains the defining question of our time. The cosmic clock continues its ancient rhythm, indifferent to our denial or our preparation. What we choose to do with the knowledge they preserved may determine whether the next chapter of human history is written by survivors or discovered by archaeologists from some distant future civilization, wondering what happened to the people who built such magnificent cities only to abandon them to the rising waters and the falling sky.